to the other areas. So first is, what is the difference between an array and a linked list?
Yeah, arrays are collections of elements stored in contiguous memory locations. They have a fixed size, which means once an array is created, its size cannot be altered. And on the other side, linked list are collections of nodes where each node contains a data data as well as the reference to the next node. Okay, so first node it will be on the data, and next node will be holding the reference. So that's in the sequence. So linked list can dynamically grow or shrink in the size, but array list cannot do that dynamic grow and shrink. So like a real time example I can give, like an array is like a row of lockers in a gym. Like we use the gym on daily basis, so you have to use them in a sequential order, and each locker has a fixed space. But a linked list is like a chain of paper clips. You can add or remove clips easily. So that's the dynamic part in the linked list, right? And like in project, you can use like in a web-based music player, you might use an array to store a fixed list of songs in an album. However, playlist, which is more dynamic and may need additions or deletions on the go, on the or in the real on the live part, so would benefit from being implemented as a linked list. So where dynamic parts are required to shrink or to grow, so their linked list, where fixed size is there only, so there it is array.
Next question is, what is a hash map and how does it work?
Yeah, sure. A hash map is a data structure that stores key value pairs. It uses a hash function to compute an index into an array of buckets or slots from which the desired value can be found. So this works on the bucket concepts. So it computes the index from the with by using the hash function on the key part of the hash map, and it identifies which index or which bucket I mean the value should go. So accordingly, the value gets stored into that bucket. Okay. So like just think of a hash map like a digital address book. You look up a person's name, that is the key in the hash map, to get their phone number. What is the value in the hash map? Okay. So you can identify quickly by that digital address book. You not to go one by one. Okay. So, like a in an e-commerce application, a hash map could be used to store user session data, where the session ID is the key and the session details like card items, user preferences, different these things are the values in the hash map.
Okay. Next question is, what is binary search tree, like a BST, right? We call, and why is it used? Why it is so useful, and why do we really use it, or in the real life, or in your project you have used it?
Yeah, sure. So a binary search tree or BST is a node-based binary tree data structure where each node has at most two children. For each node, all elements in the left subtree are less, and all elements in the right subtree are greater than the node's key. Like an example on the imagining organizing books on a bookshelf. Books are arranged in alphabetical order by title. A BST would allow you to find any book in logarithmic time by comparing book titles. So with the book titles, you are organizing with the alphabetical order. Okay, so that you can get it on the logarithmic time, what we call it, big O of whatever the big O of log in, right? We call it logarithmic times. Okay. So like if well, in the project you can use also, right, or you use it, a BST can be used in implementing a dynamic set of numbers where we can perform operations like search, minimum, maximum, insert, delete, right? Um, for instance, in a stock market application to track real-time stock prices, we can do it quickly.
Okay. Next question is explain the concepts of a queue. Where where will you use it? You can give some examples.
Yeah, sure. A queue is a linear data structure that follows the FIFO, like first in, first out principle. Elements are added from one end, which is called rear, and removed from the other, which is called front. Okay. Like a real-time example, I give a queue is similar to a line of people waiting to buy tickets at a movie theater. The first person to get in the line is the first to get the ticket, and that's the out from that line, right? So that's called FIFO. In project also we use it, right? Like in a multi-threaded environment, a queue can be used to manage the tasks. For instance, in a printing system where print jobs are processed in the order they are received. So first is requesting to print, first it is out from the print, means done. Right.
Okay. Next question is what is a stack and where would you use it?
Yeah. A stack is a linear data structure that follows a LIFO principle that's called last in, first out. And here elements are added and removed from only one end. That's called top. So in the real example, like think of a stack of plates, which we read from our engineering, right? That's an example, very, I mean, common example. You can only take the top plate off the stack and you can only add a new plate on the top. So you cannot put the plate from the down, right? Only one place uh, you can add the add or remove the plate, that's called top, right? Stacks are used for implementing functions call in programming language. So that's the function calls, right? Each function call is added to a call stack, and the stack unwinds and as function returns, preserving the return order. So, like five functions you're calling from your Java examples, right? So Java coding. So whichever comes first, that gets added, and whichever comes last, that's executes first, right? Like a leaf word.
Now let's go towards the dynamic programming kind. Okay. Uh, what is dynamic programming and how is it different from recursion?
Sure. Dynamic programming, or we call it DP, is a method for solving problems by breaking them down into simpler subproblems and storing the results of these subproblems to avoid computing the same results multiple times. So that's we store it or as a cache layer or as a history layer. Unlike simple recursion, DP optimizes by storing intermediate results, making it more efficient. So it's a quick result it can give, right? As a performance think of a DP as filling out a rebate form. Instead of doing all the paperwork each time for each rebate, you fill out common information once and use it for multiple rebates. Just like in a pathfinding algorithm for a game, DP can be used to store the shortest path to reach various points, avoiding recalculating paths repeatedly.
Cool. Next question is can you explain the concept of memorization or memory? Yeah, in DP.
Yeah, memorization is a technique in dynamic programming where we store the results of expensive function calls and return the cached result when the same inputs occur again. Yeah, real life example I'd give, like it's like having a cheat sheet while solving a puzzle. If you have already solved a part of it, you don't need to solve it again. Like again, another example, uh, when computing Fibonacci's numbers, memorization can store previously computed results to avoid redundant calculations. Again and again, same calculations, right? You don't need the previous numbers calculations again, and significantly improving performance as well, right? So you can get quick results.
Okay. Next question is, what is the knapsack problem and how would you solve it using dynamic programming?
Yeah, sure. This knapsack problem is a combinational optimization problem. Given a set of items, each with a weight and a value, determine the number of each item to include in a collection so that the total weight is less than or equal to a given limit and a total value is as large as possible. Like an example, it's like a packing of suitcase. You want to maximize the value of items packed without exiting the exceeding the suitcase's weight limit. Like we go on the air, right, in the flight. So there is a limit of the weight. So how many items maximum you can take with that weight limit. So that's on the knapsack. Like in a logistics company as well, right? Determining the best combination of packages to deliver in a single trip with the more value also, right? With the more valuable items, right? Maximizing the value while staying within a weight limit. It's similar to the knapsack, right?
Okay. Next question is, explain the concept of overlapping subproblems in dynamic programming.
Yeah, so overlapping subproblems are smaller problems that recur multiple items in a recursive algorithm. DP solves each subproblem once and stores the results, avoiding the need to solve the same subproblem multiple times. Like filling taxes involves calculating the same deductions and exemptions multiple times. Using templates like DP, you calculate each only once and reuse the same thing all the time, right? Like another example, in network routing, finding the shortest path between multiple nodes often involves overlapping paths from between few different node. I mean, same kind of nodes. So you need not to calculate again and again for that, right? For between those nodes. So DP can store these paths to optimize routing calculations, right? And you can reuse those stored or cached values again multiple times.
Okay. And next question is, how would you apply dynamic programming to solve the longest common subsequence problem?
Yeah, sure. The longest common subsequence, what we call LCS problem, can be solved using DP by defining a 2D array to store the length of LCS for different lengths of two strings. We build this array iteratively by comparing each character of both strings. Like an example, finding common DNA sequences between two species to study their genetic similarities. So you can see those common sequences, right? So another example is like in text comparison software to detect like a similarity, right, between those. We can use the LCS algorithm to find the longest sequence of similar words or sentences.
Okay. Okay. Let's go to the core Java now. Um, what is the difference between an interface and an abstract class? You can call it in the Java.
Sure. So an interface is a reference type in Java which can contain only constants, method signatures, default methods, static methods, and nested types, right? And interfaces cannot contain an implementation of methods. An abstract class, on the other hand, can have method implementations um, as well as abstract methods. So methods without a body, which you call it, right? It's the abstract method. Like an example, An interface is like a contract. Multiple companies, which we call classes, suppose, uh, can sign means like implementing, right? The same contract or same interfaces, but provide different services. That's called different services and method implementations to the different classes, right? Wherever you are writing the concrete classes. So an abstract class is like a base service that provides some default functionality and requires the inheriting companies to provide the rest. So some common functionality you are giving in the abstract class, but for the other parts, for the other implementations, the other companies or other classes need to inherit those, that abstract class and implement your own features over there. Another example, like in a payment system, an interface is called payment gateway, could define methods like process payment, while different gateways like PayPal, Stripe, right, implement the interface to provide specific processing details. An abstract class, which is the base payment, might include common functionality like logging or currency conversion, etc. So which will be inherited, right? So to the concrete classes.
Okay. Next question is what are Java collections and why are they used?
Yep. Now, Java collections are frameworks that provide an architecture to store and manipulate a group of objects. They include interfaces like list, set, and map, and classes like um, ArrayList, HashSet, HashMap, etc. Collections are like containers or storage boxes of various type of and various sizes where you can keep your items in an organized manner. Another example on the customer relationship management or CRM system, right? A list of customer could store customer records, while a map of customer ID with customer, so customer ID is the key, customer is the value part, could quickly look up customers by their unique IDs like customer ID.
Yep. So, how does garbage collection work in Java? This is the next question.
Um, yeah. Now, garbage collection in Java is the process by which the JVM automatically identifies and discards objects that are no longer needed to reclaim memory. It uses various algorithms like mark and sweep and generational garbage collection. Like an example, think of garbage collection like cleaning out a fridge or refrigerator, right? So every once in a while, you need to throw away expired or unused items to make space for new ones, right? Or another example, in a web application, objects related to user sessions might be garbage collected after the user logs out, freeing up the memory for new users, right? Yeah.
Okay, so next question is what is multithreading and how is it implemented in Java?
Yeah, multithreading is a Java feature that allows concurrent execution of two or more parts of a program. Threads in Java can be created by implementing the runnable interface or extending the thread class. So, like an example, multithreading is like a kitchen with multiple chefs working on different dishes simultaneously, each chef representing a thread or some task, right? They're doing. So, like another example, in a server application, multi-threading can handle multiple client requests simultaneously, improving performance and responsiveness.
Okay, so next question is what is the use of final keyword in Java?
Sure. The final keyword in Java is used to restrict the usage of a variable, method, or class. When a variable is declared as final, its value cannot be modified. A final method cannot be overridden, and a final class cannot be subclassed or cannot be inherited. Like an example using final is like setting a lock on a door. Once locked or assigned, you cannot change it unless you break the lock, which you cannot in Java, right? Uh, a constant value like pi, right? We write in the Java code is a scientific application would be declared as final to prevent accidental changes that cannot be changed, right? The value of the pi.
Okay. Next question is, what is the difference between double equals and equals method in Java?
Yeah, sure. So double equals is a reference comparison operator used to check if two references points to the same object. And the equals method is used to compare the contents of the two objects. So double equals is reference checks and equals method is the contents or the data of the objects. Like an example, double equals is like asking if two people um, live at the same address, right? So you are comparing the address of those two people. But equals is like asking if they look the same, right? Two people look the same. So comparing the data or comparing the content. Another example, like in a user management system, using double equals might compare if two variables point to the same user object, while equals would compare if two user objects have the same username and password. Right?
Yep. So next question is, explain the concept of exception handling in Java.
Yeah, sure. Exception handling in Java involves using try, catch, finally, and throw to manage errors and exceptions. It provides a way to handle runtime errors, ensuring the program continues running. Real life example exception handling is like installing airbags in a car. They don't prevent accidents but provide a safety net, right? Another example, like in a file handling application, a try catch block would handle cases where a file is not found, allowing the application to display a user-friendly message instead of crashing the application.
Next question is, what is the significance of the this keyword in Java?
Yep. This keyword in Java is a reference to the current object used to differentiate between class variables and parameters with the same name. So wherever there is a, I mean, for that particular class you are checking, so there we use that this dot, that variable name, right? So that it does not conflict with the same naming parameters again. So real life examples on this, like it's like a referring to oneself in a conversation to avoid confusion when multiple people have the same name, like in a Zoom call you are calling, right? So if there are multiple people with the same name, so you can refer one that this is the person in the conversation, right? So that's the this dot you're using. Like in a method that sets employee details, there is an employee class, so you can give this dot name equals name. So ensures that class's name variable is set, not a local method parameter.
So next question is, can you explain what method overloading is?
Yeah, method overloading in Java allows a class to have more than one method with the same name, but different parameters, like different type, number, or both. Like an example, method overloading is like having different keys for different doors, but all are called keys. They look similar, but they are used for different purposes. Like in a banking application, an add account method could be overloaded to create different types of accounts like savings, current, right? So add account, then in the method parameter I can give savings or we can give current account, right? So different parameters, different types of parameters we are passing in the add account, same method.
Okay. My next question is like, what is the difference between string, string builder, and string buffer in Java?
Yeah, so string objects are immutable. Once created, they cannot be changed. I mean, they cannot be changed means the object cannot be changed, but of course, the value can be changed. So string builder and string buffer are mutable. Uh, in the string, whenever you're trying to create a trying to assign a new value, so it will create a different object. In the same object, you are not able to change it anything. But in the string builder and string buffer are mutable, allowing changes to their contents. Okay, so you can change in the same object, you can change the contents. So string buffer is synchronized, or you call it thread safe, while string builder is not thread safe. So a string is like a printed document or unchangeable, okay, uh, which is already printed. While string builder is like a whiteboard, you can modify it. Okay, and string buffer is like a whiteboard in a secure room, ensuring only one person can write at a time. So in a logging system, string builder might be used for creating log messages to avoid creating multiple string objects. Okay, like that.
So, okay, now we'll go to the design patterns. Can you tell what is singleton design pattern?
Yeah, the singleton design pattern ensures a class has only one instance and provides a global point of access to it. It's useful, it is useful when exactly one object is needed to coordinate actions across a system. Like singleton is like a president of a country. There is only one, and everyone can access the president's decisions. Like a configuration manager is in an application which holds settings loaded from a file would be a singleton since only one instance is required.
Okay. My next question is, explain the factory design pattern. Some example you can give it.
Yeah, sure. So the factory pattern is a creational design pattern that uses factory methods to create objects without specifying the exact class of object that will be created. It defines an interface for creating an object, but lets subclasses alter the types of objects that will be created. Like a example, a car manufacturing plant can produce different types of cars. You order a car, and the factory decides the type based on your specifications. Like in a GUI application, a factory pattern could be used to create different types of dialog boxes, like error, warning, information, different boxes, right? Dialog boxes based on the input type.
Next question is, what is the observer design pattern?
The observer pattern defines a one-to-many dependency between objects so that when one object changes the state, all its dependents are notified and updated automatically. Like a agency releases uh, news, right? That's the called subject in the observer pattern. And a all subscribed newspapers that's called observers receive the updates or notifications from the subject. Or in a stock market application, the observer pattern can be used to update all registered users or observers about the changes in stock prices.
Okay. Next question is, explain the adapter design pattern and some examples you can give it.
Yeah, sure. The adapter pattern acts as a bridge between two incompatible interfaces. It allows classes with incompatible interfaces to work together by converting the interface of a class into another interface the client expects. Like a power adapter, right? We know it on that which we use as an adapter allows a three-pin plug to fit into a two-pin socket, adapting one interface to another, right? Another example, like in a legacy application, integration, the adapter pattern can be used to allow new modules to interact with existing modules with different interfaces.
Okay. Cool. What is so this is my next question. What is the decorator design pattern? And you can give some example on this.
Yeah, sure. So the decorator pattern allows behavior to be added to individual objects dynamically without affecting the behavior of other objects from the same class. It provides a flexible alternative to subclassing for extending functionality, right? So I can decorate some on the base object on top of it, right? Like an example, decorators are like add-ons for a sandwich. You can add extra cheese, lettuce, or tomatoes to a plain sandwich. So plain sandwich is a base object, and on top of that, you can use multiple items as a top. Another example, in a streaming service, a decorator could be added different types of subscriptions, right? Like you have taken some streaming service, or yeah. Then from on top of that, you can add different subscriptions like a TV channels, right? So you have taken, and you can add different subscription like uh, movies, right, on different movies, or cartoon channels, or on those subscriptions, right? You can take multiple things with your basic subscription.
Okay. Let's go towards some bit of Spring Boot. So my first question is, what is Spring Boot and why is it used?
Yeah, Spring Boot is a framework that allows developers to create standalone production grade Spring based applications with minimal configuration. It simplifies the setup and development process, providing embedded servers and a ready to run environment. Like Spring Boot is like a pre-assembled home. Instead of building from scratch, you get a ready to use setup that you can customize as per your needs, right? It's already ready. Just you can set up according to your own needs. Like microservices architecture for an e-commerce platform can be rapidly developed using Spring Boot, where each services like maybe these services are users, products, orders, right? In a Spring Boot application, right? You can quickly develop it.
And okay, yeah. So the next question is, how does Spring Boot handle dependencies?
Spring Boot uses a concept called starters that simplifies dependency management. Starters are predefined dependency descriptors that bundle common dependencies into a single dependency. Think of starters as combo meals. Instead of ordering everything separately, you get a complete meal with an order. So you can get multiple items in the same combo, so that you need not to order multiple times. So similarly, in the starters, you get all the dependencies with your single plate, right? Like using Spring Boot Starter Web includes all necessary dependencies for building web applications. So reducing the need of managing individual dependencies, right?
Okay. The next question is, what is the purpose of the application.properties file in Spring Boot?
Yeah, the application.properties file in Spring Boot is used to define application level settings. It allows developers to configure properties like database URLs, logging labels, and server ports. It's like a settings menu in a smartphone where you can adjust preferences like Wi-Fi, display, brightness, notification sound, these things, right? Like in a web application, application.properties might include settings for connecting to different databases, right? Based on the environment, like dev, testing, production. You can change it according to your environment.
Okay. So explain the concept of Spring Boot actuator. This is my next question.
Yeah, Spring Boot Actuator provides production ready features to help you monitor and manage your application. It includes endpoints to track application health, metrics, environment properties, and many more, right? Like actuator is like a health monitor for a car, showing oil levels, then engine health and other metrics, ensuring the car is running smoothly. Like in a microservice application, actuator can provide real-time monitoring of each service's health and performance, helping identifying issues before they impact users. Right?
Okay. The next question is, how can you implement security in a Spring Boot application?
Yeah, sure. So security is in a Spring Boot application can be implemented using Spring Security. It provides authentication, authorization, and other security features like password encryption, session management, and protection against common vulnerabilities. Spring Security is like installing locks and alarms in a house, providing multiple layers of security to prevent unauthorized access. Then in a banking application Spring Security can be used to authenticate users and authorize access based on roles. Admin user ensuring sensitive data is protected, right? Different roles this admin users, right? Depending on that, how you are giving the authorization of the uh, application, right?
Okay. And now let's go towards microservices. Can you tell what are microservices and how do they differ from monolithic architecture? Yeah, so we have the monolithic architecture. So how it is different from that?
Yeah, sure. So microservices are an architectural style that structures an application as a collection of small autonomous services modeled around a business domain. Each service is independently deployable and scalable. In contrast, a monolith architecture is a single unified unit where all components are tightly coupled. Microservices are like having a fleet of independent food trucks, each serving a specific cuisine. Whereas a monolithic architecture is like a single large restaurant serving all cuisines. Okay, so in an online shopping platform, microservices can be used to separate user authentication, then product dialog, order processing, right? These are different services, and you can scale according to your requirement, right? So allowing each to scale independently based on the
Okay. Next question is, what is service discovery and why is it important in microservices?
yeah, service discovery is a mechanism that allows microservices to find each other dynamically on a network. It is important because in a microservices environment, services can scale up or down, move to different servers, or or be upgraded as well, right? So their network locations might change frequently, like IP and all. So you need to map with your service name. An example, service discovery is like using a GPS to find the nearest gas station that may not always be in the same location. All right. So with the service discovery name, you can find it quickly. In a cloud native application, a service registry like Eureka can be used to dynamically register and discover microservices, enabling them to communicate without hard coding IP addresses.
Okay. Next question is, what is API gateway in microservices architecture?
Yep. An API gateway is a server that acts as an API front end, receiving API requests, enforcing throttling and security policies, passing requests to the backend services, and then returning the appropriate response. It acts as a single entry point for all client interactions. Like an API gateway is like a receptionist in a building who directs visitors to the appropriate department or appropriate room, right? So, like in a retail application, An API gateway could handle requests for product searches, user authentication, order placement, routing each request to the respective microservices.
Okay. The next question is, how do you handle communication between microservices? Like how, from one microservice to another microservice, how does it communicate whenever you require it?
Yeah, sure. So communication between microservices can be handled between like using synchronous protocols like HTTP or REST, right? Or asynchronous messaging using message brokers like RabbitMQ or Kafka. The choice depends on the use case and need for real-time interactions versus reliability and decoupling. So, like microservices communication is like sending a message to a colleague either by calling, that's called synchronous, or dropping an email or message like asynchronous, right? Another example, like in a finance application, real-time stock updates may use HTTP or REST for immediate responses, uh, while order processing could use a message queue to handle large volumes asynchronously. So you just order those many stocks, and right, and it will handle and it will give you update um, after some time, right? So that's what it is.
Okay. My next question is, what are some challenges associated with microservices?
Yeah, sure. Challenges in microservices include managing distributed data, ensuring data consistency, handling network latency, managing service discovery, monitoring and security, and orchestrating transactions across services. Like managing microservices is like organizing a large orchestra uh, where each musician plays their part independently, but needs to stay in sync to produce harmonious music. So, like in a healthcare management system, ensuring patient data consistency across appointments, scheduling, medical records, and billing services can be challenging due to the distributed nature of microservices.
Yeah, let's go to the microservices design patterns. Uh, the first question, what is the circuit breaker pattern in microservices design patterns?
Yeah, the circuit breaker pattern is a design pattern used to detect failures and encapsulate the logic of preventing a failure from constantly recurring during maintenance, temporary external system failure, or unexpected system difficulties. It acts like a circuit breaker in an electrical system, similar to that, right? Like example, it's like a fuse in an electrical circuit. If there is an overload of or fault, the fuse blows to protect the circuit from damage, right? So the damage does not happen due to that, so it protects the overall system. Like another example, in a payment system, if a payment gateway service is down, a circuit breaker can prevent additional calls to the service, instead returning a predefined response or error message. Right? It gives a valid response, a response has been defined earlier, or some error message it will showcase, right? Instead of showing some unnecessary errors and all, right?
Okay. Next question is, explain the saga pattern in microservices.
Yeah, the saga pattern is a design pattern for managing data consistency across multiple microservices in a distributed transaction scenario. It coordinates multiple transactions, each handled by a different service, and ensures consistency either by completing all transactions or compensating or undoing if any fails. Like an example, booking a travel package involves booking flights, hotels, cars, etc. Right? So if booking a car fails, you need to cancel the flight and hotel as well. So all over the transactions gets rollback, right? Like another example, in an order processing system, Placing an order might involve multiple services, inventory check, payment processing, and shipping. If payment fails, the saga pattern would ensure the inventory hold is released.
Yeah. So next question is what is the API composition pattern?
Yeah, the API composition pattern is used to aggregate data from multiple microservices into a single response. It is often used when a client needs information from multiple services and making multiple round trips is inefficient, right? So that time it gets used mostly. So there will be no round trips much. So from a single, into a single response, we can get all this information, right? It is often used when a client needs information from multiple services, right? So instead of going multiple trips in a single trip, I can get it. Yeah, like an example, think of an API composition as a buffet where a waiter brings dishes from different kitchens to your table in one trip. And another is like in a user profile page that displays user information, order history, and recommendations. An API composition service would aggregate data from user, order, and recommendation service, and it shows it here.
Okay. Next question is what is the strangler feed pattern?
Yeah, the strangler fig pattern is a strategy for migrating a legacy system to a new system by incrementally replacing specific pieces of functionality with new services. The old and new systems coexist, and over time, the new system gradually replaces the old. So that's the like monolith to microservices when you convert it, right? So like the pattern is like a strangler fig tree, like a fig tree, right? So that grows around a host tree and eventually replaces it, right? So that kind of um, like of course in migrating a monolith to microservices applications, you can gradually replace modules of a monolith to with the microservices, uh, redirecting traffic to the new services while the rest of the monolith remains operational. So there will be slowly movement from monolith to microservices pattern.
Okay. Let's go to the some cloud basics and concepts, right? What is cloud computing and what are its main benefits?
Yeah, cloud computing is the delivery of computing services like servers, storage, databases, networking, software, etc. over the internet. Internet here is the cloud, right? It offers flexible resources, faster innovation, and economies of scale. Like cloud computing is like using electricity from the power grid. You don't generate it yourself, you consume what you need and pay for what you use. Similarly, like deploying a web application on Amazon Web Services or Google or Azure or Oracle cloud infrastructure allows you to scale resources up or down based on traffic demand without investing in physical hardware. So the cloud provider is providing us the physical hardware. We are using their services depending on the uh, resource. Depending on the traffic, we are scaling up and down of those services and paying what we need it.
Okay. What next question is what are the different types of cloud services?
Yeah. The main types of cloud services are IaaS, what is called infrastructure as a service, PaaS, PaaS, platform as a service, and SaaS, SaaS, software as a service. So IaaS provides virtualized computing resources over the internet. PaaS provide a platform allowing customers to develop, run, and manage applications without the complexity of building and maintaining infrastructure. SaaS provides software applications over the internet on a subscription basis. Like I'll give some examples here. IS is like renting a car. You get the car, or car is a hardware and can drive anywhere, used for any application, right? According to you, you can drive anywhere. Now here, pass is like taking a taxi. You use the service, okay, like platform here to get from one place to another without worrying about driving. So you're not driving it. Driving here is like infrastructure. And SaaS is like using a bus service. You pay to use the service and follow the route provided. To whichever route it is going, you have to follow. That's the SaaS. Like example, another like using Google services computing engine, right? Computing engine is here IaaS to host virtual machines. Now there is App Engine PaaS for deploying applications, and we use our favorite Gmail, right? That is a SaaS for communication.
Okay. Next question is what is serverless computing and what are its advantages?
Yeah, serverless computing allows you to run code without provisioning or managing servers. The cloud provider dynamically manages the infrastructure, scaling, and allocation of resources as needed. Like serverless computing is like a restaurant with on-demand service. You order food, they prepare it fresh for you. They prepare the food for fresh, right? And once you are done, you leave it. Once you take the food, you can leave. No need to worry about cooking or cleaning, right? So that's what serverless computing here. Like in AWS Lambda for processing uploaded images to a web application. Lambda automatically scales based on the number of images, charging only for the compute time you use.
Okay. Next question is what are the benefits of using containerization in cloud environments?
Yeah. Containerization allows you to package applications and their dependencies into containers, ensuring consistent environments across development, testing, and production. It improves scalability, portability, and resource utilization. Like containers are like shipping containers. They standardize how goods or applications here are transported, how these goods are transported, ensuring they reach the destination intact, regardless of the ship or here it is environment. Like deploying a microservices based application in Docker containers on Kubernetes allows each service to run in isolated environments, simplifying deployment and scaling.
Yep. Next question is what is cloud native architecture?
Yeah. Cloud native architecture refers to designing, building, and running applications that exploit the advantages of cloud computing delivery models. It emphasizes scalability, flexibility, resilience, and agility. Like cloud native is like a building a house designed to withstand natural disasters using materials and techniques suitable for the local climate and conditions. Like another example in project we use it developing a real-time analytics platform using microservices, serverless functions, and managed services like databases, caching, etc. Ensures high availability and scalability.
Okay. Let's go towards little Spring Cloud. What is Spring Cloud, you think, and how does it benefit microservices architecture?
Yeah, Spring Cloud is a framework that provides tools for building distributed systems. It integrates well with Spring Boot and offers solutions for common problems in distributed systems like configuration management, service discovery, circuit breakers, intelligent routing, and more. Okay, like Spring Cloud is like a toolkit for constructing and maintaining a modular city where each module here microservice works independently but connects seamless to others. Like in a complex application with multiple microservices, Spring Cloud can handle service discovery using Eureka, centralized configuration using Spring Cloud config, fault tolerance with historics and all.
Okay. My next question is like, how does Spring Cloud config work?
Yeah, Spring Cloud Config provides a server and client-side support for externalized configuration in a distributed system. It allows you to manage configuration centrally, change configurations dynamically, and avoid hard coding configurations into your application code. Spring Cloud Config is like a centralized control room where you can change the settings of all appliances in your house regardless of their location, right? So like a digital system or home automation, right? Like that. So you can change your configuration over in a central place instead of changing everywhere. Like a retail application with multiple services like inventory, orders, user management can use Spring Cloud Config to manage environment specific configurations like database related uh, configurations and all from a central repository.
Okay. The next question is, what is Hystrix in Spring Cloud? Just before some time we called it out, right?
Yeah, a Hystrix is a library from Netflix that helps control the interactions between distributed services by adding latency tolerance and fault tolerance logic. It implements the circuit breaker pattern to prevent cascading failures and provide fallback options. An example like Hystrix is like a circuit breaker in an external system that cuts off power to prevent overloads or faults from spreading. Just before some time I called it out, right? Like the circuit breaker on the fuse part, right? So when there is overload or fault, so fuse blows up and it prevents for the damages, right? Another example, like in a travel booking application, if the hotel booking service fails, Histix can provide a fallback response, such as suggesting nearby hotels or providing default pricing, ensuring the user experience is not disrupted.
Okay. My next question is, explain the role of Eureka in Spring Cloud.
Okay, Eureka is a service discovery server that helps microservices register themselves at runtime as they start up. It acts as a lookup service, allowing services to find and communicate with each other without hard coding hostname and port. Like an example, like Eureka is like a phone directory for microservices, keeping track of addresses and allowing services to find each other by name. So you need not to remember the phone number by name, you can find it. Like in a video streaming platform, multiple microservices like user management, video catalog, recommendations can use Eureka to dynamically discover each other microservice, enabling seamless service integration.
Okay. My next question is, what is Zul and how is it used in Spring Cloud?
Yeah, Zool is a gateway service that provides dynamic routing, monitoring, resiliency, security, and more. It acts as an API gateway in a microservices architecture, handling all requests and routing them to appropriate backend services. Like Zool is like a receptionist in a large office building who directs visitors to the right department or room. Or an example we can give in a banking application, Zool can handle incoming requests for account information, transactions, and loan applications, directing each request to the appropriate microservice.
Okay, and next question on the architecture design perspective. How would you design the software architecture for a coffee machine? You can give some, what are the layers you will create, right? How will you build it? How will you build the coffee machine? What are the different layers you'll put there to build that architecture design? You can give some details on that. Yeah.
Yeah, sure. So, designing the software architecture for a coffee machine involves understanding its requirements, of course, and functionality. So that's very common. I mean, in every office we use that, right? Such as making different types of coffee, handling user inputs, and maintaining a consistent temperature. The architecture can be broken down into several components. So first one is the user interface. So it's simple display screen with buttons for user interaction, selecting coffee type and size. Second is the controller. This is the brain of the coffee machine that processes user inputs, sends commands to the other components, and monitors the system status. Then the next is beverage dispenser module. It handles the brewing process, mixing water with coffee grounds or pods, and dispensing the coffee. Fourth one is like for water heating system, maintains the water at the correct temperature controlled by a thermostat. Next is sensors and actuators. This includes sensors for water levels and temperature and coffee beans and actuators for valves and motors, right? And next is the payment processing system if it is required, like in office. This is of course not required, but in the common places like malls and all, this might be required, right? So it manages payment transactions for coffee purchases. Like an example, think of the coffee machine as a mini restaurant. The user interface is the menu board. The controller is the chef taking orders and coordinating with the kitchen staff. And the beverage dispenser is the kitchen where coffee is made and served, right? Like in designing a smart office, a smart coffee machine, you could integrate IoT capabilities, allowing users to operate the machine via a mobile app. The machine's software would include modules for Wi-Fi connectivity, cloud-based user preferences storage, and a scheduler for brewing coffee at specific times.
Cool. We'll go some bit of on JavaScript part. Uh, what is the difference between where, late, and const in JavaScript?
Okay, yeah, where it declares a variable that can be reassigned and is function scope. It is hoisted to the top of its scope, but the initialization is not. Let declares a block scope variable that can be reassigned. It is also hoisted but not initialized until the declaration is evaluated. And const declares a block scope variable that cannot be reassigned. It must be initiated at the time of declaration. Like using where it is like having access to a public locker in a gym. So you're giving as a public locker in the gym. You can leave things there and anyone can access them anytime. Right? That's the where. Late is like a locker in your room. Only you have the access and control, right? And const is like your safe deposit box. It's secure and unchangeable once you place something inside. Like in our project, right, in a web application, use late and const to manage state variables within a function to prevent accidental reassignment and to maintain predictable behavior. And where could lead to bugs due to its broader scope, making late and const preferable for modern JavaScript development.
Okay. This question is, what is the concept of closures in JavaScript?
A closure is a function that that retains access to its lexical scope, even when the function is executed outside of that scope. Closures are created whenever a function is defined inside another function, allowing the inner function to access variables from the outer function. Like closures are like keeping a spare key hidden outside your house. Even when you are away, the outer function is done. That means you still have access to your house. The inner function can access the outer functions variable this way, right? So in a web application, closures can be used to implement data encapsulation and maintain state. For instance, creating private variables and methods within a module that are only accessible through privilege methods defined within the closure.
Okay. Next question is how does the event loop work in JavaScript?
The event loop is a mechanism in JavaScript that handles asynchronous operations. JavaScript is single-threaded, so the event loop allows it to perform non-blocking operations by handling events and executing callbacks after the main call stack is empty. Like call stack is where the function execution context is added, and callback queue where callbacks are added after asynchronous operations. And event loop checks if the call stack is empty, and if it is, it pushes the function first callback from the queue to the stack. Like an example, the event loop is like a receptionist managing incoming calls. They answer the phone like call stack, take notes like a callback queue, and handle each call when they have a free moment. Like in a project in a web server handling multiple requests, right? The event loop allows the server to continue processing other requests uh, while waiting for IO operations like database queries and all right to complete, ensuring efficient handling of multiple concurrent connections.
Okay. Next question will go towards the database. What is normalization in a database and why it is so important?
Okay, normalization is the process of organizing a database to reduce redundancy and improve data integrity. It involves dividing large tables into smaller, related tables and defining relationships between them. The main goals are to eliminate duplicate data, ensure data dependencies make sense, and, and simplify the structure. Like an example, normalization is like organizing your bookshelves. Instead of putting all your books in one pile, you categorize them into different shelves based on generation, author, or other criteria, right? Making it easier to find a specific book without duplicates. Like in a project in a e-commerce database, normalizing involves creating separate tables for customers, orders, products with relationship defined for foreign with the foreign keys. Right? This ensures that updating customer information in one place reflects everywhere it's referenced, preventing inconsistencies.
Okay. Okay. Next question is like, what are acid properties in a database?
Yeah. ACID stands for atomicity, consistency, isolation, and durability, which are key properties that ensure reliable transactions in a database system. Atomicity is it ensures that each transaction is treated as a single unit, which either completely succeeds or completely fails. Consistency guarantees that a transaction brings the database from one valid state to another, maintaining database rules. Isolation ensures that concurrently executing transactions do not affect each other's execution. And durability ensures that once a transaction is committed, it will remain so, even in the case of a system failure. Like acid properties are like the processes in a safe deposit box. You either place the entire content securely inside, that's called atomicity, follow all security protocols, that's called consistency, operate without interference from others, that's called isolation, and ensure contents are safe even during a power outage, that's called durability. Like in a project, right, in a banking system, when transferring money between accounts, asset properties ensure that the transfer is processed completely or not at all, keeping the account balances consistent and preventing interference from other transactions.
Okay. My next question is like, what is indexing in databases and why is it useful?
Yeah, indexing is a database optimization technique that involves creating a data structure to improve the speed of data retrieval operations on a database table. Indexes are created using one or more columns of a database table, providing a fast lookup for query execution. Like an example, an index is like an index at the back of a book. Instead of flipping through every page to find a topic, you can quickly locate the exact page number where the information is found at the index page, right? So you can quickly turn around to that page. So that's how this indexing happens, right? And on a project like in a large user database, creating an index on the email columns speeds up the search process when validating user logins, significantly reducing the time required to find specific user based on their email address.
Okay, cool. So I think that's all from my side. So this was the comprehensive interview on the different topics on the different areas of backend as well as front end on the cloud, microservices, design patterns and all. Of course, the architecture design as well on the DSNL Go, right? So that's all. Thank you so much.